How are you, everybody who is watching this video? I would like to take this opportunity to welcome all the online students, and also I would like to take this opportunity to welcome some physical engineering students. If this is the first time to meet me, my name is Olenjolai. I am a Tanzanian, and I thank God who have given me a grace and anointing on teaching and also doing some business of electronics and telecommunication engineering. I would like to take this opportunity to welcome you into this practical program, and the name of the modules that is called the Intermediate Practical Electronics and Telecommunication Engineering. It's very practical programs, however, that we are going to discuss about theory, simulation, and even the practical part. So this is the workshop. We are in workshop 1. We are still in chapter 1. We have almost 10 chapters in this course. So I would like to ask you that to make a follow-up. And in case you missed the previous workshop, which is workshop 00, you can access it in our official YouTube channel that's called Online Bachelor Polytechnics of Tanzania, and also Online Diploma Polytechnics of Tanzania. So those are the two channels where I actually provide these contents. So in case that you need to know about the requirements for this course, the prerequisite of this course is fundamental of practical electronics and telecommunication engineering, which we have covered already. But in case also you miss those skills, it's not a great deal, because I am the one who taught that course. I know how can I make sure that you understand this concept. So the requirement for this course, especially for today's workshop, just a fresh mindset, and also you should have an exercise book, should have a pen, should have a pencil, because we are going to have some drawings in today's workshop. So welcome in workshop 1. We are done with workshop 00, which is called the IR sensor module. So let us start with just a quick review of what we have discussed in previous workshop. Briefly, quick review of workshop 0. But I did not appreciate some engineering students. Students, how are you? Yes. How are you, students? Yes. Oh, are you ready for this program? Yes. Wonderful. That is good. So in previous workshop, what did we discuss? First of all, I introduced to you about contents that we are going to cover in this module. And in that list of the contents, we say that the first thing that we are going to cover is sensor. Say sensor. Then we are going to discuss about bipolar junction transistor. Say bipolar junction transistor. Then we are going to discuss also about electromechanical. Say electromechanical switches. Say electromechanical switches. Gentlemen, say electromechanical switches. Okay, so I said gentlemen then. So then we are going to discuss MOSFET. Say MOSFET transistors. We are going to discuss about 5-5 timer. Say 5-5 timer. We are going to discuss about basic logics, which means that NOT gate, AND gate, and OR gate. We are going to discuss also about universal gates, which is actual NAND gate, NOR gate. NAND gate, and what? NOR gate. And I will tell you that why do we call them universal gates. Then I told you that we are going to discuss about motors and what? Buzzers. These are the what? Are the transducers. Then the next part, we are going to discuss about encoder and what? Decoder. This is all about telecommunication. So we'll actually design a wireless digital RF transmitter and wireless digital RF receiver. Then we are going to discuss about what? RF transmitter, and we are going to discuss about what? RF receiver. And hence, the last topic I told you that I'm going to teach you about soldering and desoldering, especially on Vero board. This is a serious program. We ask students to pay attention and to concentrate and to love the subject. Are we together? So then I gave you how many definitions of the sensors? 4 definitions of what? Of sensors. What is a sensor? Sensor is what? A device or a module or a machine or what? Okay, you forgot, huh? Then, system. Then we say, I just gave you 20 examples. 20 examples of what? Of sensors. Then I left the homework. And the homework is mention 20 other examples of what? Of sensors. So my students who have attended that workshop did that homework, and they told me that before this workshop that they did it, and I would like to give them a chance to come and present about what they have found. So they mention 20 sensors, and then we'll continue with today's workshop, which is IR sensor module. But we'll start with, first of all, about sensor module, because by that day, you just mentioned that a sensor can be a module, or can be a device, or can be a machine. Are you together? Are you together? Are you ready to listen, to hear from our students? Yes. Okay.
Okay. Hi, my fellow students. In front of you, my name is Ruben Gosbet. I'm here in front of you so as to present some types of sensors that some examples of my sensor of sensors that I have found according to the homework that we have given in the last workshop. So I need your attention so as to hear for what I found to you. Yes. So the first sensor that I found is color sensor.
You may just write in the second column. Color sensor. Say color sensor. So it senses your color.
Okay.
Like your eye. Can you sense color? Yes.
The second one is rain sensor.
Rain sensor. Rain. Say rain sensor.
Rain sensor.
So it senses what? Rain.
Next.
You have rain in our daily life? For example, rain, what does it affect when it rains? Process. Right? When you have left some process or some maize which are drying out of the sunshine or in the sun, then in case it rains accidentally, then you find that your process are wet.
Okay, next is real-time clock sensor. Real-time
clock sensor.
clock.
Or in short, you call it RTC. Real-time clock sensor. This you can find in your smartphone or in your computers. For instance, for your smartphone, you can switch it off, and once you turn it on, you don't need to adjust the time. So it will just read the time automatically. Right? You may take even the battery out. For instance, the featured mobile phone, you call it you can take the battery out. When you return it, there's no need for you to actually correct about the date and correct about the time. Why? Because there is a real-time watching. Okay? Okay?
Next one is flexi sensor.
Flexi sensor. Say flexi sensor. Say real-time sensor. Say real-time clock. So flexi sensor, its function is actual. Whenever that sensor is sensing bending, then it gives an output. A flexi sensor is used mostly when the designs of the, we call them disabled people. Disabled people. For example, those people who used to communicate by using sign language. How do we call them?
Deaf.
Deaf. People who have hearing problems. Right? Hearing and even speaking problems, right? How do we call them? And we used to call them special group. So they use fingers to communicate. So they can wear a flex sensor. And when, for example, they bend this way, the interpreter can interpret that what does it mean. But flexi sensor usually has different applications. That's one of them. Okay?
Next is water flow sensor. Water flow sensor.
Water flow sensor. Where is it? This one. This is water flow sensor. So it measures flow rate by using what is Bernoulli's principle. You remember Bernoulli's principle in fluid mechanics? Huh? You remember or just you heard? You remember? So can you write the Bernoulli's equation there? Next time, not today.
Okay, next, accelerometer sensor.
Sometimes that water flow sensor is called the flow rate sensor. So right there in bracket, flow rate sensor. Flow rate sensor. Accelerometer sensor, but I've mentioned in my trade example. Oh, that is digital accelerometer and this is the accelerometer. No, still the same. Okay, continue.
Next, knock sensor. Next, cam sensor.
Cam sensor.
Yes.
What the means of cam sensor? Camera sensor. Cams and applications of the web camera.
Next is coolant sensor.
Yes?
Coolant sensor.
Coolant.
Coolant.
Sensor.
Yes.
Where do you used to find it? Refrigerators. You know that most modern refrigerators they have sensors in the cooling part. Man, hatugia hata freezer la milango mitatu, milango minne. Okay. Basi kuna sensor pale ambayo inakuwa inapima kiwango cha kiwango cha baridi. Kwa hiyo ikifikia kiwango fulani inazima. Sawa.
Next is NOx sensor.
Don't know anything about NOx.
Next is map sensor. Next, parking sensor. Next, oxygen sensor. Next, voltage sensor. Next, crank sensor. Next, throttle sensor. Next.
And so class A, cam sensor. Continue. Coolant sensor. NOx sensor. And map sensor. Parking sensor. Oxygen sensor. Voltage sensor. Current sensor. And number 19, number 17 is what?
Voice sensor.
Voice sensor.
Yes.
16. Voice sensor, instead of voice sensor, just write a sound sensor. It's not a voice sensor, it's called the sound sensor. Proximity sensor. Put there between 18 and proximity sensor. Class A, sound sensor.
Sound sensor.
Proximity sensor.
Proximity sensor.
Can you pronounce the sensors from number 1 to number 20 quickly?
Color sensor.
You.
Yes.
You're the one who have a microphone. Pronounce for us.
Color sensor,
Color sensor,
rain sensor,
rain sensor,
real-time clock sensor,
real-time clock sensor,
flexi sensor,
flexi sensor,
water flow sensor,
water flow sensor,
accelerometer sensor,
off-flow rate sensor,
off-flow rate sensor,
accelerometer sensor, NOx sensor,
NOx sensor,
NOx sensor,
cam sensor,
cam sensor,
coolant sensor,
coolant sensor,
NOx sensor,
NOx sensor,
map sensor,
map sensor,
parking sensor,
parking sensor,
oxygen sensor,
oxygen sensor,
voltage sensor,
voltage sensor,
crank sensor,
current sensor,
throat sensor,
throat sensor,
sound sensor,
sound sensor,
proximity sensor,
proximity sensor,
gyroscope sensor,
gyroscope sensor,
metal detector.
metal detector sensor.
Metal detector sensor.
Wonderful. So let us congratulate him. 1, 2, 3. Hongera. Mara. Wow. Thank you very much, Mr. Ruben.
How are you, everybody? I am among of students who attend this class every day. My name is Pil Nasibu. Today I'm here to show 20 examples of sensors. First one, it is a color sensor.
Let's say color sensor.
Color sensor.
The second one, it is microphone sensor.
Sensor, say microphone sensor.
The third one is UV sensor.
UV sensor, ultraviolet sensor. UV sensor.
The fourth one is water flow sensor.
Water flow sensor. Say water flow sensor.
Water flow sensor.
The fifth one is proximity sensor.
Proximity sensor. Is it proximity or proximity?
The sixth one is rain sensor. The sixth one is speed sensor. The seventh one is air quality sensor. The eighth one is force sensor. The ninth one is GPS sensor. The 10th one is barcode scanner sensor.
Barcode scanner sensor.
The 11th one is radiation sensor. The 12th one is radar sensor. The 13th one is magnetometer sensor. The 14th one is air quality sensor. Level sensor.
Include the quick review.
There's carbon dioxide sensor.
Carbon dioxide sensor. Say carbon dioxide sensor. Carbon dioxide sensor. Carbon dioxide sensor. Ruben mentioned the oxygen sensor. So now we have carbon dioxide sensor. While myself I mentioned just the general gaseous sensor. So I say gaseous sensor, it should include a number of sensors. Electric sensor, carbon dioxide sensor, nitrogen sensor, a number of sensors.
There's flame sensor.
Flame
Sensor.
sensor.
There's gesture sensor.
Gesture sensor. You know meanings of gesture? Say gesture. You know meanings of gesture? Huh? Really?
Yes.
What does it mean about what the meanings of gesture? Gesture.
Inside.
Huh?
Inside.
Pardon?
Inside.
Mm-hmm.
Pulse oximeter sensor. The 19th one is ECG.
Pulse oximeter sensor. Mm-hmm.
ECG sensor.
ECG sensor.
And the 10th one is gyroscope sensor.
What the long terms of ECG sensor or ECG? ECG is applications of electrocardiogram. Say electrocardiogram. 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 Cardiogram is a word from cardiac. Cardiac means heart. Number 20 is what?
Gyroscope sensor.
Okay, I think that Kelly has done well. So let us congratulate her. 1, 2, 3. Gera. Imara. Thank you, Nasibus Dauta.
Hi, my fellow learners.
Hi, Yakim.
I would like to appreciate your presence and invite you as we can continue to enjoy the beauty of electronics engineering. Here in front of you is your fellow learners, Yakim and Guru Emmanuel, and we are in front of you as I can perpetuate the work done by my fellow learners Ruben and Pili. By listing just a few numbers of sensors we have in our real world. The first sensor is all about the distance measuring sensor. The distance measuring sensor. The second is all about the light to voltage optical sensor. Light to voltage.
So the distance measuring sensor. Say distance measuring sensor. And light to voltage optical sensor. Say light to voltage optical sensor. Pronounce it here like him again.
The light to voltage optical sensor.
Light to voltage optical sensor. So that once we use it in optic fiber.
Yep.
To convert light into voltage. And the light is from the optic fiber, because remember in electronic circuits, light is not allowed to flow. What you expect to flow is electric current. Right?
The third one is all about the dust or particle sensor. Dust or particle sensor.
Dusty or particle sensor. Say dusty or particle sensor. That's very important in electronics engineering, because most electronic systems are sensitive or well affected by dusty or particles.
The first one is all about the blood glucose sensor. Blood
glucose sensor. Say
glucose
blood glucose sensor.
sensor. This type of sensor is used to monitor the glucose levels in your blood, so as to monitor diabetes. The fifth one is all about magnetic sensor.
Magnetic sensor. Say magnetic sensor.
This type of sensor is used to detect the presence of magnetic field lines or forces. The sixth one is all about water quality sensor.
Water quality sensor. Say water quality sensor. Sometimes that one's called turbidity sensor. Say turbidity sensor. Measure the pH of the water.
The next one is all about strain gauge sensor. Strain gauge.
Strain gauge. Strain gauge sensor. You remember about strain? Inelasticity. So that is strains of machine.
Strain gauge sensor. The next one is all about the barcode scanner sensors. Barcode scanner sensor. The next one is all about the current sensor. The current sensor. This is used to detect the presence or the flow of electric current in a given circuit.
Current sensor. Say current sensor. Very important sensor in electronics.
And the next one is all about the Hall effect sensor. Hall effect sensors.
Hall effect sensor.
The Hall effect sensor.
Hall effect sensor. Hall effect sensor. For those students who have gone through A-level education, do you remember the concept of Hall effect?
The next one is all about this
You
proximity
remember the
switch
those students who have gone
sensors.
for A-level education. You remember the Hall effect concept in electromagnetism? You remember?
The next one is all about the biometric sensors. Biometric
sensors. You know biometric sensors where are we using? For instance, at BHE in Block A, ground floor, there is a biometric sensors where all the staff have to sign in and sign out. I think you used to see, right? It's a one dealing like whenever that you are for the staff. For instance, if you are reporting, you have to sign. So use your fingerprint.
The next one is all about position sensors.
Okay? GPS tracker
Sensor.
sensor. Say GPS tracker sensor. GPS the abbreviation of the word is global positioning sensor.
Weight sensor.
Position sensor. Say position sensor. Weight sensor. Say weight sensor.
Level sensor.
Level sensor. Level sensor is just like the liquid level sensor or water level.
The level sensor is used to determine the level of liquid or solid in a container. The next one is all about the UV light sensor. UV light sensor.
Can you write down there? They are being left. You still have, I think, 3 sensors.
Yeah. I thought just repetitions.
For the remaining.
Yeah.
All the remaining sensors.
Yeah.
Can you mention them?
Just map sensor and sound sensor.
Map sensor and sound sensor.
Yeah.
So let us appreciate the presentation of Eliakimu. 1, 2, 3. Hongera. Imara Eliakimu. Okay, so now we have mentioned, my students have mentioned almost 60 sensors. When I've been teaching you workshop 00, I mentioned 20. Some of them are just repetitions of what we have discussed. But let me just try my level best to summarize or to tell you in summary about the main functions of these sensors. For the 20 sensors that I've mentioned, the first one is infrared sensor. This is the one that we are going to discuss and we are going to learn because it doesn't need the computer programming. So infrared sensor, the main goals for this sensor is to detect an obstacle, the presence of what? Obstacle. And this presence and the presence of the obstacle might be between the transmitter, because this sensor it has 2 parts, transmitter and the receiver. So the transmitter is IR or infrared emitter, and receiver it's a photodiode. So for instance, in case of electric elevators doors, we have infrared sensor. One is emitting the infrared and the other one is receiving. So when there's a blockage of that signal, then the door will not close. Are we together? Are we together? So whenever you think about designing a particular system where that actually you need that obstacle to be detected, then this might be a good sensor for you. Okay? The second one is called PIR, or passive infrared sensor. Passive infrared sensor is say that it detects human electromagnetic radiation. According to the previous theory, say that everybody which has a temperature above 0 Kelvin radiate electromagnetic radiation. Peter, are you there? You are not there. So PIR sensor, it means, for instance, my temperature is 30 degrees centigrade, so 37.5 degrees centigrade. So always I'll be radiating electromagnetic radiation. So PIR sensor can sense the radiations I radiate, but it cannot sense the radiation that a cat or a dog or a cow radiate. However, that they are also animals like us. Are we together? It cannot irradiate, it cannot sense. For instance, the room temperature for you might find is 24 for this room. So 24, it means that everybody in this room radiate electromagnetic radiations according to the previous theory. Because 24 degrees centigrade is more than 0 Kelvin. Because it will be 24 plus 273 Kelvin. Are we together? That is the main function. So whenever you want to design a system which you need to detect people, say people. Say people. Whether the security system, whether, for instance, that you want just to design maybe automatic gate, so but maybe or the automatic lighting system, for instance, that automatic lighting, you want to design a system that the lights will be on when there is a person inside the room, right? So this sensor might be a good sensor because it will detect a human being. So if for instance that the entrance of the dog or a cat, the lights will never be on. Are we together? Then the third sensor I mentioned is smoke sensor. Say smoke sensor. So say smoke sensor. So this one, it's used to detect smoke. And why do we need to detect smoke? Because in some scenarios, when we have smoke, we expect to have a fire break. So that's why we need this system in order to give us an alert. Right? But in some scenarios, smoke is not required to be given out. So maybe if there's a smoke, then you have to notify the owner of the system. Okay? Okay? That's the functions of what? Smoke sensor. But there's another sensor which is relating with the smoke sensor, which we call it flame sensor. Say flame sensor. So this one detects only flame. It cannot detect smoke. And smoke sensor cannot detect flame. It just detects smoke. Remember that whenever we have flame, there is the smoke. Right? But whenever we have the smoke, the flame is not important. Are we together? Eh? So flame sensor to detect what? Flame. Okay? Okay? And in most cases, this is used as what? Security systems. In tall buildings, for instance, that if there's a fire break, then these sensors are the one that provide notifications or providing an alarm. Are we together? Yes. The next sensor is soil moisture sensor. Say soil moisture sensor. So soil moisture sensor, this is the sensor which can detect the moisture of the soil. So whenever you think about agricultural project, so for instance, flame sensor and what? Flame sensor and smoke sensor, those are the good sensors for fire detection system. Fire detection. For instance, in most rural areas, people, they use actual that just to establish fire without any particular rule, right? To burn the forest. So you may have these systems in order to detect, to do the early detections and to notify maybe. These systems are usually used especially in national parks, right? So provide a notification that there is a fire break or the expected fire breaks are in the particular location. Or there's expected fire. For instance, flame sensor and smoke sensor can be used also to as just we call them fire extinguishers or fire detection system in most of the tall buildings. Right? Are we together? So soil moisture sensor and then soil moisture sensor. This is used in agriculture just to measure the amounts of the moisture in the soil. But also you have temperature sensor. We say temperature sensor, we have two types of temperature sensor. Room temperature sensor and human temperature sensor. So room temperature sensor, in case you want to design a system which is actually detecting the room temperature. Or maybe, yes, the room temperature. For instance, in test 1, if you do remember, in electronics product fabrications and electronics drawings, I asked you to solve a problem existing in W15.4. So what should be the input of your system is room temperature sensor or temperature sensor to measure the amounts of temperature within the building. Are we together? Are we together? The human temperature sensor is it's just like a thermometer. We have glass thermometer, we have mercury thermometer, we have digital thermometers. So I think that you know them. Okay? Also they are sensors because they sense body temperature. Okay? So those body temperatures or body temperature sensors are very important if you are designing the biomedical system or you are designing a system maybe to monitor the health of the patient or maybe the health of the person. They are very important. As electronics engineers, also technicians, you have to think them, right? Yes. Then the next one, we say the pressure sensor. We have two types of pressure sensors. We have atmospheric pressure sensor and we call it human pressure sensor. Right? Atmospheric pressure sensor measure the pressure of the atmosphere or atmospheric pressure. Right? In what? Millimeter mercury. Or in what? Newton per meter square. Or in what? Pascal. Okay? The human pressure sensor, it's the one that we use to find the hospitals. Where that, you know that it means that it has to measure at this point, right? Those are the biological pressure sensors. And I think that there's some of electronic system in these rooms that where we had it. You know that when you are solving a problem, sometimes you find that you need even those. Okay? The next sensor is gas sensor. Say gas sensor. So we have a number of gas sensors, more than 10 gas sensors. Ruben mentioned the oxygen gas sensor. Yes, it is there. Then Pili mentioned carbon dioxide sensor. So oxygen sensor detects what? Presence of what? Oxygen. Carbon dioxide sensor detects what? Presence of carbon dioxide in a particular place. Right? But also we have what? LPG gas sensor. But also we have what? Nitrogen gas sensor. But also we have what? Methane gas sensor. Ethane gas sensor. Propane gas sensor. Butane gas sensor. Okay? Carbon monoxide gas sensor. Nitrogen monoxide gas sensor. So you can, with the gas sensors, you can see the real applications of the chemistry that you have been learning. Are we together? Are we together? Sometimes in some of the articles they call it environmental sensor. Environmental sensor or pollution sensor. Pollution detection sensor. Something like that. Are we together? So the main functions is to detect a particular gas. Okay? Okay? So if you want to design a system or to implement a system which is detecting gas, be familiar in your mind that we have a number of gas sensors. Hello, Robert? We have a number of what? Gas what? Sensor. It's just a matter of which gas do you want to detect it. Are we together? Yes. Then we have humidity sensor. Say humidity sensor. Yes. For instance, you want to design maybe automatic meteorological system. Maybe the systems to measure all the atmospheric parameters of this place, of the particular place. Then humidity sensor is very important because we'll measure the relative humidity. Say relative humidity. Say relative humidity. Yeah, so, and this one called the atmospheric relative humidity. Are we together? So it detects what? Humidity. Then you have digital accelerometer sensor. Digital accelerometer sensor is the one that also Rubens mentions as what? Accelerometer. Right? So what does it do? Digital accelerometer? Detect what? Tilt it, Simply detect acceleration. Okay? Then the other sensor is laser sensor. Say laser sensor. So laser sensor, this is the sensor which has two parts. The first one is laser emitter. Say laser emitter. And laser receiver. Say laser emitter and laser detector. Say laser emitter and laser detector. Say laser emitter and laser detector. Laser, it's a type of car. It's a one type of the visible light. There are some materials which are actually producing laser. Laser, it's visible. You can see by your naked eyes. Okay? Okay? So we are using also these laser sensors in some places where we need, because there's a laser, for instance, this is laser transmitter or laser emitter, and this is the laser receiver. So in case there is a blockage, then something might be sent to the control unit. Are we together? Yes. Are we together? Yes. Then the next sensor is called the pH sensor. Say pH sensor. Yes. Say pH sensor. Yes. What is pH? pH is the negative logarithm of what? Concentrations of hydrogen ion. pH is what? Negative logarithm of what? Concentrations of hydrogen ion. pOH is what? pOH is the negative logarithm of concentrations of what? Hydroxide ion. You learned the chemistry and then you left it. So pH sensor, this is the sensor which is detecting the pH of the solution or liquid. Are we together? So if you use the pH sensor, this sensor, it can detect the amounts of the pH. If it is 0.5, if it is 2, because you know from the pH scale we have, the pH scale starts from 0 to 14. Right? From 0 to 14. So 0 to 6.9 is what? Acidity. 70 is what? Neutral. Right? 7.1 up to 14 is what? Basicity. You forgot them. And especially that most of you are from PCM. From what? PCM. So chemistry is your aunt, not your father. So your father was physics and your mother was what? Pure mathematics. But chemistry was what? Your aunt. Okay. So that is pH what? Sensor. Is it clear? So is it clear? So whenever we mention our pH, whenever we discuss about liquids in electronics, so liquids have different parameters. One of the parameters, every solution has a pH. Okay? So you might say that, okay, I want to design a system maybe to measure the quality of water or the quality of milk or the quality of maybe, let's say, of hydrogen peroxide in hospital, maybe the quality of what, of honey or the quality of tea, right? And then you'll be asked the questions, which parameters are you going to focus on? Oh, one of them is pH. Right? Are we together? Yes. Yeah. So pH sensor, you can encounter it whenever you are dealing with where the physical phenomena is what? Liquid or solution. Okay? Yes. Then we have vibration sensor. Say vibration sensor. Vibration. So this is the sensor which detects what? Vibration. We have different places, for example, for the motor vehicles, most of the parts vibrate. Right? So vibration sensor detects what? Vibration. Then another sensor that I mentioned is touch sensor. Say it's touch sensor. So this one is a sensor which senses what? A touch. Right? So for instance, touch sensor can be used where? Maybe at the entrance gate. Right? So you touch the sensor, then the gate open. You don't touch the sensor, the gate does not open. This is the digital sensor, right? It's not fingerprint sensor, it's touch sensor. Fingerprint sensor is something else. Okay? Okay? Another sensor we mentioned is coin acceptor sensor. Say coin acceptor sensor. The simple example of coin acceptor sensor is what? I told you Heritage Company, which is providing what? Water. You just put 500 there, and then you get how many liters? 2 liters of water. Right? So what actually are introducing the coins that we call the coin acceptor sensor. It accepts what? Coins of different dimension. In Tanzania, we have only 4 coins. A coin of 50 shillings, a coin of 40, 100 shillings, Pasco, Peter, 200 shillings, a coin of 40, 500 shillings. So the question is, how does it distinguish those coins? This question, yes, the answer is very simple. It can distinguish those coins by using their dimensions and features. All those 4 coins have differences in dimension and features, and especially thickness. Good luck, you are not concentrating. Are we together? So the dimensions of 50, coin of 50, and dimensions of 500 is completely different. So how do they know that this is 500 Tanzania shillings? That's a good question. They know because before we install them in the particular place, the coin acceptor sensor has to be trained about the particular coin. If you want to train it to detect 500,000, you can place before you install to the site, right? You just take a coin acceptor sensor itself, and then you train to accept 500. So you can actually introduce 500,000, 500 shillings 10 times. Once it accepts it 10 times, it records into the memory. So next time, if a particular service is dedicated for 500 Tanzania shillings, if you introduce 500, you will get it. If you introduce 200, it will reject. Are we together? Yes. Are we together? And the goodness of that coin acceptor is just to differentiate them by using puzzles. And puzzles is all about digital signal. Okay? So if you are thinking about designing a particular system, and the input of that particular system is money, then coin acceptor has to come around. Also, we have not acceptor, but it's not common. Coin acceptor, it's a common one, right? So if you are thinking that, you know that in your home place, these most conductors, maybe they have problems. Why should we not introduce a system that where the client or the passenger has to do the prepaid? So you have to think about coin acceptor, right? Are we together? Coin acceptor sensor. So that's what you have to develop your mind. Then we have ultrasonic sensor. Say ultrasonic sensor. So ultrasonic sensor, it uses sound Doppler effect to work. It has a transmitter and receiver. So what does it do? It sends a sound to a particular distance. When that sound face an obstacle, there is a reflected sound. That reflected sounds will be received by the receiver and send the information to the controller of that sensor. Then it can tell you the distance. So ultrasonic sensor, this will use it to measure the distance or the height or the level. Are we together? Are you together? Are you together? So itself, within it, it has a transmitter and receiver. So it just sends the sound wave, and then this, whenever that we have a obstacle, because the transmitter and receiver are located in the same position. When there's a obstacle, there's a reflected what? Rays. Right? It's similar to the radar sensor. I think that one student, Pili, mentioned about radar sensor. Say radar sensor. So radar sensor send electromagnetic waves, which is light wave, to the incoming target. And then some of that wave will be reflected and received by radar receiver antenna and processed. Then it can detect or it can actually measure the range. Radar can measure range, can determine radical velocity, can determine direction. So I spoke about ultrasonic, because ultrasonic use sound Doppler effect. Radar sensor use light Doppler effect, that the one we have covered in wave and vibration. Are we together? So radar sensor, it actually measure distance or range. We call it range. Then this ultrasonic sensor also measure what? Distance. So sometimes in some of the articles, that's why you find that they call it distance sensor. Actually, we don't have distance sensors. We just have some sensors which either use sound or electromagnetic waves to measure the distance. And what is happening actually, the sensor propagates a wave, and then that wave will be reflected. Then from there, the calculations should be done to mention the distance between the obstacle and the sensor. Are we together? Tell your neighbor, sensors are beautiful. Tell your neighbor, sensors are beautiful. Oh, so your neighbor is not happy. Then the next sensor is light sensor. Say light sensor. Say light sensor. Say light sensor. So light sensor, it senses what? Presence of light. And I gave you a simple example. LDR, which is light dependent resistor. Light dependent what? So light dependent resistor is actually that changes the resistance according to the amount of what? Of light. When there's a light fall, resistance decreases. When there's a darkness, resistance what? Increases. So in case that you want to design a system which you need it to work during night, then light sensor is very important. Why? Because your system has to work during night. During the morning, there is a sunrise. So when there's a sunrise, it means that amount of light which will be falling on your sensor. So when there's amount of light which is falling on the sensor, resistance will decrease. So you can tell the control unit to switch on the system during the daytime. When there is sunset, right? Sunset, then there's a darkness. So if there's a darkness, it means your system will detect that now it's dark, it's night. Let me turn it on. So that sensor is good when you are designing a system that requires it to work during the night or to work during the day. Are we together? Yes. Are we together? Yes. Because sometimes you might be solving a problem that existed during night. Sometimes you may be solving a problem which exists during the day. Or sometimes you need a system, there's no necessity. If the system needs to work is required to work at night or required to work in the evening, during the daytime. So if it's not required for that system to work at night, it's better to turn it off to save power and also to reduce the running cost. Are we together? Are we together? For instance, if you're designing agriculture, you want to do watering. What's the right time for you to do watering? During night or during the day? Huh? Class, I asked you, we are from the families or peasant. We call them peasants or agricultural families. In case you want to water the plant, is it good to water during the daytime or during the night? During night, eh? So if you have irrigation systems, better to turn it during the night and turn off during the what? The day. Okay? Yes. Okay? So LDR will be required for that case. Then we have load cell sensor. Say load cell sensor. So load cell sensor, it works like weight sensor. You see weight sensor? Eh? So load cell sensor, this is the sensor which is used to measure or detect the weight or the mass of the object placed on top of it. Can I repeat? Load cell sensor is the sensor which is used to measure or to detect the weight of the object placed on top of it. Right? So if you want to deal or you want to design a system that actually focusing on the weight of the objects, then load cell sensor will be a good starting point for you. Are we together? Are we together? Are we together? Load cell sensor is mostly used in weight bridge station. You know weight bridge station? Sehemu zenye mizani ya kupima magari. Do you know it? Eh? Eh? But for those who were born in Dar es Salaam, they have never traveled out of Dar es Salaam, they don't know it. Is it? But for we from up country, we know them. Eh? But also it depends, because it might be sleeping from the beginnings of the Jan to the end. Okay, then another sensor is called the tilt sensor. Say tilt sensor. So this is the sensor which is only detecting what? Tilt, but in one direction. Digital accelerometer detecting tilt in 3 dimensions. X-axis, Y-axis, Z-axis. Okay? Okay? Then we have heartbeat sensor. Say heartbeat sensor. So this is the sensor which can detect what? The heartbeats. Whether your heartbeats, what the heartbeats, the human heartbeats in 1 minute. Your heart should beat how many times? 72. So if it beats 78 in 1 minute, something's wrong. Peter, if your heart beats 60 times in 1 minute, something is wrong. And we are approaching to die. Okay, good. So that's heartbeat sensor. So there's a close relationship. Heartbeat sensor is completely different from electrocardiogram sensor. Electrocardiogram sensor, this is just a part of electrocardiogram biomedical machine. Say electrocardiogram biomedical machine. Say electrocardiogram. Electrocardiograms, it's a biomedical machine. So that electrocardiograms is actual, do the measurements of the human body by using the sensor. That's why we have ECG sensors. Are we together? Are we together? Then we have alcohol sensor. Say alcohol sensor. So this is the sensor. So electrocardiogram sensor, this comes important when you are thinking about designing electrobiomedical system. Electrobiomedical system. ECG sensors are very important for that case. Pulse oximetry sensors are very important for that case. Okay? So electrocardiogram sensor are just what we have discussed. We have alcohol sensor. Say alcohol sensor. So alcohol sensor, this is very important, especially in the places where the alcohol is prohibited. So if you have taken some alcohols, you are not allowed to enter that place. So this sensor will be there in order to check if you are in hangover or you are in hang. Because you speak, when you have taken alcohol, instead of phlegm, then you are speaking gesture. Are we together? So alcohol sensor to detect what? And that is very important in our village places. It's better to install at home. When our fathers come from there, okay, so so the system can detect them. Father, today you have taken some alcohol. No. Okay, come. You see? Okay, so those are the twin sensors I've mentioned. But we have color sensor. I think that some students mentioned color sensor. Say color sensor. So color sensor, this is still general. Because we have a red color sensor, we have a blue color sensor, we have a green color sensor. Actually, this one is detecting the color. Okay? So you can design a system which is actually detecting what? The color. Where is it important? Maybe in primary school, right? Because colors are there known, right? Every student, every pupil in primary school has to wear what? A white shirt. And what? A blue shirt, a blue pants and what? Or a blue skirt, right? So there's no need for the teachers just to inspect that what the color of this one. So you can have a color sensor there and then check. If colors are different, then prohibited. You're not allowed. Then the next one, rain sensor. Say rain sensor. This one detecting what? Raindrop. Say raindrop. Rain sensor also we are using in meteorological system. Say meteorological system. For instance, you hear TMA, Tanzania Meteorological Association, every evening they provide, or every morning, they provide about what? Weather forecasting or weather prediction. Right? So one of the sensors used there, it is what? Rain sensor. Maybe you are designing a system, a special rain sensor. We use often this system maybe just to give a notification, to give you notification in case that you have some crops that maybe they are, you have taken them out in order to be dried by using the sun rays. Or rain sensor can be used in the agricultural system, where that you have irrigation system, right? So in case it rains, the irrigation system has to be off to budget. Right? Right? Yeah. Then real-time clock, I've explained about that. Real-time clocks, real-time clock sensor, this actually, okay, we call it sensor because the input, but simply this is the real-time clock. That's all. Real-time clock. So the main function is just to keep time and date. Right? To keep time and date. So listen, where do you use real-time or RTC? Listen, in electronics you use real-times or RTC in case that we are designing a project where that the parameter of time is important. Let's say, for example, I design a project and then say I want to program. Whenever it reaches 2 p.m., maybe the system has to turn on. So a real-time clock will be important for that case. And then whenever it reaches maybe 6 p.m., the system has to be off. Right? Whenever it reaches, let's say, 9 a.m., the system has to be on. And if it reaches maybe 12 p.m., the system has to be off. So for that case, if that's the idea, it means that the real-time clock might be there. Because it's the one that can monitor time. Are we together? Yes. And the goodness of real-time clock, you can design a real-time system. You know meanings of real-time system? It can provide you information now. But again, in case that you want to send information, you want to design a system which is sending information to another place, let's say a server, after 1 hour. Say after 1 hour. So it means that your project works and then after 1 hour send information to a particular authority or to a particular destination. Then real-time clocks will be important because we'll actual program. After 1 hour, it means send the information to this destination. So how are you going to program? When it reaches maybe 7 a.m., send the information. 8 a.m., send, and to release send the information. Because if we have advanced practical electronics and telecommunication engineering, we'll be using this real-time clock and we'll see how does it work. Okay? So this is the actual introduction of the sensors. In the next modules, I think that every week we might be learning about one sensor. Because sensors is what buildings, electronic systems, and it's the input. It's one of the hardest part. If your sensor work, you're in one stage ahead. If your sensor failed to work, to detect the signal, then you have failed. Okay? Okay? Flexi sensor is the one that actually, when you bend, you change the resistance, and then you can sense something. Right? Right? Water flow sensor, or water or flow rate sensor. Say flow rate sensor. So this one is the one which measures the rate of flow of water in particular point. In case you want to design systems which you want to integrate with the WASCO water system, right? Then the flow rate sensor is important because it's the one that can measure the amounts of water which are flowing through the particular point within a particular time. Okay? 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 So the principal operations, I'm not talking about principal operations, I'm telling you its main function. Just to measure the flow rate of water, flow rate of liquid. So flow rate, the word rate is something over time. So flow rate means flow over time. Okay? So in case you want to design a system for tempering, water tempering, say water tempering. Say water tempering. And you can design a system where that maybe Mr. Pasco tempered the Wasco system. It means that Mr. Pasco, we say that he's a sieve of the Wasco system. He's actually consuming water without paying water bill. So you can design that system. Okay? Okay? Then NOx sensor, I don't know. Camera sensor, I think that you know the function of the camera sensor. Coolant sensor, we are using in refrigerators. NOx sensor, I don't know. Map sensor, yeah, map sensor, it's a little bit general. I'm not familiar with it about map sensor. Parking sensor, say parking sensor. Parking sensor, this is the sensor actual that used in parking places where we used to park cars. In some of the developed countries, there are sensors which actually give the information to the driver that you have parked at the right place or you did not park it at the right place. So those sensors are fixed at the parking place. For instance, Stemol is the one that one of the nearest place where they have a large parking, right? But there's no sensors. But you can install some sensors actual to make sure that you budget, because the aims of sensors to budget, right? To budget the parking. But those sensors also can give the information of the driver at a distance that there's no parking. Just to go to the next place where you can park your cars. Right? Right? Okay. Then we have what? Oxygen sensor. I've discussed about that. Voltage sensor. Say voltage sensor. This is the sensor which measure voltage. Current sensor is the sensor which measure current. So voltage sensor is actual works like a voltmeter. Current sensor is work like an ammeter. Okay? We have DC voltage sensor, we have AC voltage sensor. We have DC current sensor, we have AC current sensor. So if you want to design a system which is dealing with current or dealing with voltage, you don't be limited. You have sensors to perform the work that you want them to perform. Okay? For instance, you want to design system that to just for the current protection system, or maybe voltage protection system, over voltage protection system. Those sensors are very important because they will measure if the voltage exceeds a particular amount, then the system will be off, or maybe the device will be isolated from the power system. Are we together? Are we together? Crank sensor, I don't know. The other one, what is reto sensor, I don't know. Sound sensor, this one detects what is sound sensor. We had sound sensor. Okay, sound sensor. Sound sensor detects the sound. So in case you want maybe to design, we call it verbal system. A system that where in case you talk a word, then maybe something will happen. Okay? For instance, open the door, then the door gets open. Close the door, then the door will be closed. Do you like it? Yes. So you enjoy electronics at your home place, right? So it means that that's the main functions of sound sensor, right? Yes. Then we have what? Proximity sensor. Say proximity sensor. So what the function of proximity sensor? What the means of proximity? Proximity is the word come from approximation, right? So what is proximity? This is the sensor which is actually uses electromagnetic waves to detect the level of proximity. You can find it in elevators. Then the other sensor is a gyroscope. Say gyroscope sensor. Say gyroscope sensor. Gyroscope sensor, this is the sensor which measure what? Detect what? Orientation and the rotation. Orientation and the rotation. Then metal detector sensor. This is a very important sensor in industries. In most of the industries, if you pass, I think that you have gone. Have you seen those policemen that have something that to check if you have some coins or some iron materials? If you have an iron, say, teet! Do you know them? Eh? Have you ever seen them? Those policemen at the entrance gate to check you. They can actually scan. Do you know them? So that is a sensor. It's what? Metal detector sensor. It detects what? Metals, either keys or coins. Are we together? Yes. So maybe you want to design a system that detects the metals. That's okay. Then the other one is what? Speed sensor. Okay, so this is to measure the speed. Then air quality sensor. Air quality sensor is just what we talk about, gaseous sensor. There is a force sensor. Say force sensor. To detect what? Force. What is force? Mass times acceleration, right? Then GPS, global position station sensor. Say GPS sensor. So this is the good sensor for global positioning station sensor. If you want it to detect or to know the longitudes, the latitudes, the altitudes where you are, this is the very important sensor. We used to have in something called GPS module. So the GPS module is actually give your system the physical location. Okay? The physical location. If you want maybe to have a system and you want to connect with internet, then you want to know its location. Maybe you want it to embed your systems into the car or into the motorcycle. For instance, the GPS, you can embed it in the motorcycle. Then actually you can actually see all the times where is your motorcycle by using the internet, because there is a GPS satellite. Are we together? Yes. Are we together? Yes. Then we have barcode sensor. Say barcode sensor. Can I have your ID? Can I have your ID? So this ID, okay, can I have the oldest one? Yes. This ID, you see, it has a barcode. This is called barcode. Say barcode. So here, you see this part where we have actually shadow. There are the unique numbers for each identity card, for each OTS identity card of DIT. So if we can scan in barcode sensor. So when you scan, the barcode sensor compare the codes within this barcode and the code registered in the saver. If the codes are the same, then you can allow to access the information or to access the entrance. If the codes are different, then this is illegal ID card. Okay? That's what we call barcode sensor, right? So those are very important for unique identification system. That maybe you say, for myself, I want to design a systems to help maybe to solve the problems maybe in DH, right? So in dining, every student has to scan what to use the barcodes. I will be using the barcodes in order for the students to scan the ID. So any illegal ID will be actually rejected. Okay? Are we together? Then the other one is called radar sensor I've discussed. Magnetometer. Say magnetometer. This is electromagnetic sensor. I don't know it well. I don't know if there's any students who are familiar with magnetometer. Then pulse oximetry, I've discussed it. The distance measuring sensor, I told it's either radar sensor for the long distance or ultrasonic. Actually, don't have distance measuring sensor. It's not there. But some articles used to measure distance sensor. Right? 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 Is it clear? Either ultrasonic or radar. Light to voltage sensor. Say light to voltage sensor. Light to voltage sensor, where is it? Light to voltage sensor, this one we use often in optic fiber. In optic fiber. And optic is fiber what? This is the receiver part. Because in receiver, light has to be converted into electric energy. In optic fiber transmitter part, electric energy has to be converted into light, which is visible light. Are we together? Are we together, class? Yes. Are we together? Yes. Then dusty or particle sensor. This one to detect what? Dusty or particles. How can you use this sensor? This is good because most electronics components are damaged by the dusty or particles. Okay? So if you want to design a system where the dust is detected or particles is detected, and maybe you turn on the fans or do some cleanness, this might be a good sensor for you, for that system. Okay? Then blood glucose sensor. I think that Eliakim has explained about that. To measure the amounts of glucose in our blood. Do you know that if you have less glucose, what happens to our body? Eh? What is going to happen to you? You have less glucose in your blood. You don't know. Okay, so try one day. Then you have magnetic sensor to detect the magnet. Water quality sensor. Water quality sensor. So water quality sensor, here we have a number of sensors. Hello, Faridi? We have number 40 sensors. When we discuss about water quality sensors, we have to check different parameters. So this is still a general word. But have in your mind there is water quality sensor. But actual water quality sensor is not there. We used to call the names just a turbidity sensor. Turbidity sensor, pH sensor, and sometimes I think that there are almost 4 or 5 parameters which measure the water quality. You cannot say that maybe there's a particular sensor. Yes, so there are some intelligent sensors which integrating all the 4 sensors together, and we can call it a water quality sensor. Okay? Okay? But they are a little bit expensive if we find that 4 sensors integrate together. Then strain gauge sensor. Say strain gauge sensor. Strain gauge sensor, this is the sensor dealing or measuring the strength of the material. Just like a strain. The concept of strains we taught in elasticity. We talked about strain. We talked about stress. We talked about what? Young modulus. We talked about what? Shear modulus. We talked about what? Bulk modulus, etc., etc. Then you have what? Barcode, I've discussed it. This is what? Current sensor, I've discussed it. Hall effect sensor. Say Hall effect sensor. So Hall effect sensor, this is the sensor which is actually used to measure currents of electric field and magnetic field. Then proximity switch, we discussed biometric, we discussed GPS. Position sensor, I'm not sure. I don't think if there is a physical, there's a separate position sensor. I'm not sure about that. Weight sensor, measure the weight, but not weight of all the stuff. Remember some of the stuff we used to measure by using load cell. Okay? Okay? So weight sensor is used in some scenarios. Level sensor, we don't have actual. Okay, level sensor, most of the articles they write level sensor, but simply we use just ultrasonic sensor to measure the level of water in the tank in order to actual that maybe to trigger the water pump to pump the water. If there's a, just see if the level of water is low. Okay? Okay? Yes, but most of articles just write level sensor. Color sensor we discussed, yeah? UV light sensor to detect what? Ultraviolet light. What it means of ultraviolet light? It's one of the spectrums of the light spectrum, right? It's the 50 band from radio frequency. The first one is what? Radio frequency or radio wave. Say radio wave. The second spectrum is what? Microwave. The third one is called what? Infrared. Then visible. Then ultraviolet. Then gamma ray. Then X-rays. So that is UV light. Then carbon dioxide, I think that gyroscope sensor. Gyroscope we discussed, yeah? So up to this time, I think that you are familiar, you know about 80 sensors. 80 sensors. Or maybe let's say 70 sensors. And you know what do they perform. So it means that let us change our today's title. This is all about sensors. Say that examples of sensors. Students, if you get a general concept about sensors, okay, so if that's the case, this is the end of today's workshop. What we have just actually covered, different examples of sensors and what do they perform. Make sure that this should not be the end for you. Go and find some other sensors. We have hundreds and hundreds of the sensors in this world. Sometimes you may not use them at the same time, but actually, once you know about different types of sensors, you won't be limited in your thinking and won't be limited that these things or these problems is not possible to be solved in electronics. Are we together? Remember that sensor is an input unit of any electronics and telecommunication system. So you have to make sure that you master it, you learn it, you make a follow-up of it, because it will simplify your thinking. Because sensor interact with the physical environment. Interact with the physical environment. That's why that's very important. It's even very important compared to the parts which do not interact with the physical world. Because to change the physical world into the electric energy, it's something a little bit challenging. So if that's the case, thank you very much. I think that the homework that I want to leave it to you, go and review all of these 8 examples of sensors and make sure that you write them in your mind and you try to think, where can I use this sensor? That's the homework of today. Let me repeat the homework. The homework is this one. Go and review all the 70, more than 50 examples of sensors that I've taught you. And when you are doing revision, you should not just read the names like gyroscope sensor. You have to think, according to what I've been taught, what the main function of this sensor, and how can I use to solve a particular problem in my environments or in my own country. That's the homework. Okay? Okay? Try to do even for at least 10 sensors. Then you'll find from there, your mind is open. It's no longer limited like previously, that you don't know how to model real-life problems and solve by using electronics concept. Are we together? Thank you very much. See you in the next workshop.
Africa.